A very good afternoon to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this exclusive webinar on future of water sustainability and the tech-driven solution for the same. The session is organized coinciding with the World Water Day scheduled on March 22nd. I am Roopa, Assistant Secretary General at BCIC, and I am accompanied by our Secretary General, Colonel Harish, who is with me, who has joined the webinar. I welcome Mr. Arjun R, who is the Managing Director of Paryaavarneer Engineers and Consultants, who will be addressing on today's webinar. Thank you, Mr. Arjun, for accepting our invitation to be part of the webinar. I also welcome Mr. VC Mohan, who is the former Senior General Manager, EHS Management at Bosch Ltd, who is the Chairman of our ESG Expert Committee. The committee is also co-chaired by Mr. Rajesh, who is the Country Environment and Sustainability Manager at ABB India Limited. The Chamber acknowledges the support of our annual sponsors who are supporting all the activities of the Chamber throughout the year. I now request Mr. VC Mohan to take it over from here, introducing the speaker also. Thank you very much, and I request all the participants to share in their queries in the chat box for the moderator and the speaker to respond to your query. And I'm sure you will have very good and best key takeaways to take away from this webinar, from today's deliberations. Thank you very much once again, and over to you, sir.
Thanks, Roopa. Thanks for the coordination. And I should say thanks to all the participants first for joining this call. It's important that we should use different platforms for exchange of information. And as far as EHS is concerned, it's a continuous learning process. The technology is developing the problems we are facing, environmental challenges related to sustainability, or the challenges are becoming more prominent as year on year. So it's always important to have a platform for exchange of information as far as various aspects are concerned, whether it is resource conservation, waste management, managing carbon neutrality, or the issues related to circular economy. So this is one of such a platform within BCIC. The ESG committee organizes these programs. So I would also like to invite Arjun for this webinar. Thanks, Arjun, for considering our request and joining here. Because there are two things. One is what we read and what we understand, and other is what we learn through operation and management. So when these two come together, the what we know as a technology or what we know as the recent developments, along with the organizational experience, operational experiences only can give the complete understanding of the issue, and wherein it becomes easy to find solutions to the challenges. As you know, 22nd March is the World Water Day. This World Water Day was, I think it was started in the year 1993. It is mainly to conserve fresh water. As you know, the fresh water, we have limited quantity of fresh water, and most of it is available in the ice caps and the glaciers. And because of the global warming, these ice caps are melting beyond certain rate, which is supposed to be there. And certainly one day we will have a lot of challenges, especially for a country like India, which is a tropical country. We have, even though we get rainfalls and an average across the country around 600 to 800 millimeter per year, this comes within a span of 3 to 4 months in the year, and rest of the year we need to manage the water. So it's important, and this year the theme for this year, World Water Day, is also about glacier preservation. If you look into many of the videos which are available in the even though in the internet about the glaciers, you see a lot of scary pictures where glaciers are eroding very fast. So this is where it's important as people coming from the industries, because for industry, water is also an important resource, a raw material for us. And we can ensure that what we call as business continuity if we have only water security for our industries. This is true for water intensive industries and also for non-water intensive industries. So today, let us make this webinar interactive. And Arjun, with his practical experience, more than 12 years, you would be able to take us through some of the learnings and latest technology what we have for managing the water and the wastewater. In fact, I come from the background of Bosch, where I worked for 24 years. And of late, in last 3-4 years, we have used technology to our advantage. Because for us in Bosch, we have locations starting from Rajasthan in the north till Tamil Nadu. And water security is one of the major concerns. And using technology, we have been able to secure the water at our locations. But it's a continuous process and the challenge is always there. And since water is a natural resource, it also brings in its own challenges. We cannot hold all the water, we cannot harvest all the rain, within our premises. Then there will be some social issues around our locations. So all this we need to consider. So before Arjun takes over, Colonel, do you have some comments to make?
No, sir, go ahead. You can go ahead. Thank you.
Yeah, Arjun, over to you. And for the participants, you can put your questions on the chat. And also in the end, let us have some good time for interactions. Over to Arjun now.
Yeah, thank you, Mohan sir. And thank you, Roopa madam, and thanks BCIC for giving us this opportunity. So I will be starting with the presentation. Is visible?
Yeah, go ahead, Arjun.
Yes, it's clear.
Welcome to all the participants for this webinar on future of water sustainability and in knowing the tech-driven solutions. So why this topic was chosen and for this World Water Day is, so there is a very big need for addressing the water conservation actually. So there is a lot of problems that are happening with respect to water. You know about those who are in Bangalore know about water scarcity, water pollution, and also other problems related to water like availability in some regions. So there are a lot of problems that not only in Bangalore, even the entire country or even in most part of the world, we are facing problems with water. So what are the advanced technologies or tech-driven solutions that we have to overcome the problems with respect to water is something that we are going to cover in today. So water is a resource which is available in plenty in the world, but it's about how we manage it. If somebody says that water is not available, it means there is some lacking with respect to management also. So because in one part of the country there will be flooding and in another part of the country there will be a scarcity. So it's all about managing it in an efficient way to ensure that water is available for all. So if you look at some data with respect to water scarcity, so globally around 783 million people do not have access to clean and safe drinking water. That is one of the major problem with respect to scarcity and again management. And in water pollution, around 1 in 5 deaths of children under 5 is due to diseases from unsafe drinking water or unsafe water. So this is a very big concern with respect to the human health. And there are more alarming numbers here. In India, around 80% of water sources are surface water is polluted. This is as per the CPCB sources. And around 40% of the water is lost when it is supplied through a pipe systems. This is considering across India landscape. And almost more than 70% of the groundwater reserves in India are overexploited. So we are overly dependent on groundwater also for our water requirements. And almost 60% of water loss in irrigation is happening because of inefficient practices or outdated practices that are still being followed in the agricultural irrigation. So this is a context of what are the problems that we are facing with respect to water and its management. And then we will explore about what are the options or solutions that we have with respect to the water and wastewater treatment and management. So with respect to treatment, so treating water, it is not a trouble. So it's all about having some outdated practices or conventional systems that give or that do not meet the requirement of the treated water in terms of quality or quantity. So there are treatment systems, conventional treatment systems, which fails to meet the quality standards, and the incoming characteristics are more than the design parameters. It might be seasonal changes or new contaminants need the advanced treatments. So there are a lot of inefficiencies and inlet variabilities that lead to the failure of some conventional treatment systems that are being currently used for water and wastewater treatment. So what we can come out, how we can come off from this problem is having an operational management challenges in well-designed plants. So one is, and the other problems that we face in operational management challenges in well-designed plants is manual operations, cost inconsistencies. There will be high energy and chemical use, which again is a very OPEX intensive thing. There is no real-time monitoring, which directly contributes to delays in decision taking and delays in addressing the concerns. Then there's no or poor data logging in a lot of the manual operated plants. There is no data logging at all. So so nobody knows what is actually happening in the treatment plant, whether it is actually performing, running. Nobody knows about it. So these are some of the problems that we face with the conventional systems with respect to the plant systems or with respect to the operations management. So we have a lot of advanced water and wastewater treatment technologies that are available in the market, which are already well proven in the market and already being established in a lot of industries. There are a lot of industries who are already implementing most of these advanced treatment technologies. But there is a very big scope for plenty of other industries also to join this. And some of the technologies that are there are membrane-based treatment, that is with respect to reverse osmosis, ultrafiltration, nanofiltration, RO, so MDR. So all these options are available under membrane treatment system. We have advanced oxidation process in which ozonations, UV peroxide and Fenton process are available. ZLD technology, which is a very hot topic today, and a lot of industries or a lot of industrial regions are compelled to achieve zero liquid discharge from their industrial premises. So there are a lot of ZLD technologies that are available, which are proven, like MEE, MVR, LTE, or TVR. And also we have application-oriented technologies like it may be seawater reverse osmosis, which are very much essential when we go for an coastal region industrial belts like Chennai. So now Chennai is dependent a lot on this seawater desalination technology, electrodialysis reversal, or multi-stage flash distillation. So these are some of the advanced water and wastewater treatment technologies that are available in the market, which are proven, running successfully in a lot of places, and which can be implemented in other areas to achieve better results and conservation of water. So we will go with some of the technologies in the coming slides. So this is the comparison of membrane technology. We'll be first starting with the membrane technology, in which there are different membrane technologies that are available: microfiltration, ultrafiltration, nanofiltration, reverse osmosis. So each membrane processes are used for different purposes. It is not that one membrane technology can meet all the requirements in any place or in any industry. So we have to carefully choose what is that we require, or what is the output that we expect from this treatment. So once we have this clarity and we are very clear about what is the input that we are giving to this membrane treatment systems, so then we will be able to get a very high efficiency and output from these membrane technologies. So membrane treatment is a physical separation system. There is no reaction happens, or there is no or there is no any other biological thing that happens in the membrane. So it's purely a physical filtration systems, which happens because of separation of the solids because based on its pore size. So this I will be explaining. And with respect to membrane process, each membrane process requires different level of pressure or its permeability. So all these matters depend on the membrane type, membrane MOC, and the water being used. So this is a particle separation chart, which you can go through. Microfiltration, UF, NF, and RO are all designed for some particular particle separation. So it is not that each or any of these membrane systems can filter any of the particle which is mentioned in this. So if you go under microfiltration, so it can remove paint pigment, it can remove the human hair, or whichever is more than 5 micron, it can easily remove. When we come to ultrafiltration, it can remove virus, bacteria, silica to some extent, and carbon black. So like this, UF is generally designed when we want good water, when we want to purify the water by removing the suspended solids present in the water. Then comes nanofiltration. Nanofiltration is used for removal of certain specific types of ions that we require. For example, if you want to remove only like calcium from the water and you don't want to remove any other ion from the water, then we can use nanofiltration. Like this nanofiltration is generally used when we have to selectively remove some ion from the water. Reverse osmosis is something that is used to remove the dissolved solids present in the water. So most of the aqueous salts, metal ions, or all these things can be removed from the reverse osmosis. So reverse osmosis is one of the highest level of membrane filtration that is currently available in the market, and which is being widely used also. So this chart can give a very clear understanding about which membrane filtration system can remove what type of material from the water. So you can see here microfiltration up to some extent can remove bacteria and suspended solids. Ultrafiltration for sure can remove virus, bacteria, and suspended solids, but it will allow the monovalent ions or multivalent ions to pass through its membranes, because this ions particle size is less than the particle size of less than the pore size of the filtration. Generally, the ultrafiltration membrane will be having a pore size of 0.01 micron, but these ions particle size will be even less than that. So in nanofiltration, based on the membrane pore size and type of the membrane that we are using and the ion which we have to use, we can remove some of the multivalent ions from the water, and some will still pass through. Monovalent ions we cannot remove through nanofiltration, but in reverse osmosis we can remove all these things. It may be monovalent ions or multivalent ions. So all these things can be completely removed from the reverse osmosis system. But considering that, since as per this, if the suspended solids can be removed from the reverse osmosis, but we cannot feed suspended solids into the reverse osmosis. If we give this, the pores of the reverse osmosis membrane will get blocked. So we have to ensure that first it is passed through ultrafiltration and then sent to our reverse osmosis to ensure a long life of the RO membranes. That is the general practice that is being used in all the places. So this is about the membrane filtration systems, and for which pollutant removal or which particle removal we can use what type of membrane. So based on this, we can choose the filtration system as per our own needs, and the entire treatment systems can be customized accordingly. So, and we will be dwelling little deep into the membrane bioreactor. So, membrane bioreactor is one of the advanced technology that is available for the sewage treatment and effluent treatment. So, whichever water that is having, which is organically, which contains organic pollutants, we can use membrane bioreactor to remove those pollutants from the water. So So this is the general flowchart of the membrane bioreactor, in which there will be a screening system at the initial stages. Then there will be oil grease removal. Then it comes to the equalization tank, where the incoming water is mixed for 8 hours to achieve the equalized water characteristics. Then it is fed to anoxic tank and aeration tank, where the important biological degradation happens, and then it is fed to membrane tank. So as I said earlier, the membrane which is used in membrane bioreactor is also a physical separation system. Even though a sewage treatment plant or effluent treatment plant will contain chemical and biological treatment units, like it may be flash mixer or clarifiers or anoxic tank and aeration tank, which is shown here, which is biological. But in membrane tank, there will be no biological reaction that will be happening. So membrane tank will contain only the membranes which are used for separation of solids from the water. In conventional treatment systems, what we generally do is we will use the clarifiers or settling tanks to separate the water or MLSS from the water that is coming from the aeration tank. But in membrane tank, what we do is we use the membranes which are equivalent to ultrafiltration membrane quality. So and pore size also. So which will ensure that the suspended solids or MLSS present in the water is separated from the water and again put back into the anoxic tank, and the treated water will be clear from the suspended solids and BOD and COD. So this treated water can be used for industrial purposes or for any other requirement of the industry. So there are a lot of industries who are using the sewage treated from this MBR membrane bioreactor system back to their industrial processes. Maybe it may be steel industry, cement industry, power industry. So all these industries require a huge amount of water, and this treated water will be as good as your ultrafilter treated water. So hence this can be directly used for your process, considering the TDS and other requirements. It will be very, very clear. And this is the most advanced technology that is there for sewage treatment and effluent treatment, which gives a very high quality of treated water consistently. So that is a very important thing. It gives that result very consistently. So this membrane bioreactor is a combination of activated fluids process and membrane filtration. So and instead of settling the MLSS, the membrane is used to separate the water and solids in the sewage. So hence we get a very good quality of treated water. And MLSS is generally maintained in the range of 8,000 to 12,000. That is about this. You can see here a membrane surface against which the water containing solids and water is pushed through, and because of the pore size of the membrane, the solids gets remain on the surface of the membrane, and only water passes through the membrane. So that is because this is a semi-permeable membrane which allows the water to pass through, but not the solids which are more than the pore size. And these solids are recycled back or removed from the system as per the requirement. So these membrane bioreactor systems can even remove bacteria and viruses. So that is also another advantage. So it will be even bacterially, it will be free from the contaminants, like it may be virus, bacteria, it may be even any type of virus and bacteria also. All these things can be removed in this membrane. So this is how a typically membrane bioreactor module would look like. So there are two types of membrane bioreactor systems that comes with. One is flat sheet and hollow fiber membrane. This is a hollow fiber membrane reactor module that we are showing here. So the left side picture is of the module and the right side picture is of the cassette, which will be directly immersed in the membrane tank, and the permeate is sucked out from the system using the permeate pump. So this is and this is the treated water quality that we can get from the MBR treatment plant. It may be an STP or a TP. This quality of treated water is for sure that we can get, provided the designs are done in a proper way. And this will be having BOD, COD of even less than 5 or less than 10, which meets the legal requirement and also the reuse requirements in most of the industries. And even COD will be less than 30 or less than 50. TSS will be less than 1 or even sometimes not detectable also. Turbidity also less than 1. So we get a very pure water from this MBR system. This MBR system is very helpful when you want to reuse the water. If you want to use the water only for gardening purpose, then we may recommend some other technologies. But considering if you want to reuse the water for your process, or even for some other, if you want to again further treat it with RO and use it for some other purposes, then MBR is the most suitable option that you can use. And even when we use this MBR system, it will even simplify your process. For example, if you have a conventional treatment plant which is having aeration tank, settling tank, sand filter, carbon filter, so this MBR tank coupled with aeration tank can replace this entire treatment system. So that is another big advantage that MBR will have. So some of the major advantages of the MBR system is you get a very high quality of treated water from this with BOD less than 5 and COD less than 20. Treated water can be even directly used for cooling towers, treated through RO, and in some foreign countries, they are even using for drinking also after good quality of disinfection. There is no water generation, and it requires very less area compared to all other existing technologies for sewage treatment or effluent treatment. But yeah, it comes with some disadvantages if we consider it like that. It's a high installation and operating cost is required. It requires skilled manpower for operation and maintenance, and we have to change the membranes periodically, which is not there in some other conventional treatment technologies. But to get a very high quality of treated water and to reuse it, I think it is worth to go with this technology, considering water as a very scarce resource and scarce resource, and considering that water availability in lot of industrial areas is very difficult to get water, especially when we come to summer seasons. Even the government also cannot supply water, considering they have to first supply it for drinking purpose. So this technology helps to reuse most of your treated water that is most of your wastewater. It may be sewage or effluent, and helps to reuse it for your process. So this is about MBR that is generally used for sewage treatment and effluent treatment. What we can, or even what can be done is, if you already having some conventional treatment system, that is, it may be an ASP or SPR or MBBR, we can even, UF can be even integrated to that to get the treated water quality almost equivalent to MBR. I do not say it will be exactly equivalent to MBR, but very near to MBR quality we can get from the UF system also. So this can be done when you already have a treatment system, but you don't have any space to expand, but you want to get good quality of treated water, and MBR cannot be installed due to some constraints. So then this is one of the better solutions that can be looked into. Its advantages are the upgradation can be done without any new construction and without much changes in the existing treatment scheme. That is a very major advantage. Cost of installation is not high as MBR. But as I said, water quality will be almost equivalent to MBR. And this UF kit will be available in plug and play type also. So you do not have to go for very major engineering changes in your treatment plant. You can just have your UF kit installed and directly feed your conventional treatment plant treated water to UF directly, considering it meets the inlet water quality requirements. The filter water TSS should, the disadvantages or the drawbacks I can say is, the feed water that we are feeding to the UF should be having TSS less than 20 or less than 20 milligram per liter. Otherwise, the membrane can clog very frequently. Because this is a pressurized system, UF is a pressurized system and MBR is a submerged system. So submerged system can handle more solids compared to pressurized system. So hence, in pressurized system, we have to maintain less solids in the feed water. And again, there will be membrane replacement cost as equivalent to as MBR membrane replacement cost. So this is the drawback. Then we'll come to the reverse osmosis that we use for the desalination or even in industrial processes. So we all know, we might already knowing the reverse osmosis. Osmosis is an forward treatment system where the pure water and the solids, dissolved solids, will get separated because of the osmotic pressure through the semi-permeable membrane. But in what happens in reverse osmosis is for the solution that is already containing the dissolved solids, we will apply a pressure because of which only the water will pass through the semi-permeable membrane and the dissolved solids will get separated from the water through the semi-permeable membrane. So that is the reverse osmosis concept is. This reverse osmosis has played a very vital role in water conservation. Wherever we get treated water having high TDS, which cannot be directly used for the industrial processes or for reuse in cooling tower, boiler, chillers. So we can have a reverse osmosis system from which we can get up to 80 to 90% of recovery of water, which can be directly fed to the industrial process. So that is a very important technology that is being used for water conservation and water reuse in industries. So this is a typical seawater RO system. Like as I said, in coastal regions where we do not get fresh water or water having low TDS, we have to depend on seawater desalinations only, where we take the seawater and pass it through the pre-treatment and then through the RO system to get a very high quality of treated water, which can be used for the processes or even for drinking in some places. And the reject is again let back into the sea back. So this is a typical seawater RO system flow diagram, in which there will be many stages of treatment that happens in RO. Generally, there will be starting from 2 stages up to 5 stages. The treatment systems will be there, depending on the inlet TDS and other characteristics. So in seawater reverse osmosis, there will be a pre-treatment in which there will be filtration through filters. The sand or carbon filters will happen. Then there will be chlorination and dechlorination. There will be adding of chemicals like antiscalants, and there will be cartridge filters. Then it is fed to reverse osmosis, where there will be RO membrane will be there, through which it is passed using the high pressure pump, which helps to get more recovery and less quantity of reject. And even the permeate will be having lesser TDS, which helps to reuse the water. And post treatment, we'll be doing the gasifiers or pH adjustments depending on the requirement, and which can be directly reused. So we can even convert seawater having around 50,000 or 60,000 TDS, having around 60,000 TDS to even TDS less than 100 or 200 TDS using the RO system. So that is the advantage with RO systems, which helps to reduce the freshwater consumption and for reuse of the recycling of the treated water. In a lot of industries where if you want to achieve ZLD, RO is a very important part, where the treated effluent is passed through UF and RO, and then it is fed to the ZLD. The RO reject is fed to the ZLD, because ZLD operation is a very costly affair. So as much as we can reduce the ZLD sizing, it will be helpful to reduce the cost of operation and even the capex cost. So reverse osmosis plays a very important role in that, in which we can reduce the reject quantity that is being fed to the evaporator system and get more recovery of water. So this is till now we have talked about the advanced technologies that are there for water and wastewater treatment. Even with this advanced water and wastewater treatment, one important point is if we have a manual operation system, or if we have a very unskilled team to operate the plant, then again these plants are going to fail. So automation is something that is very, very important in nowadays, considering the lack of availability of skilled manpower to operate these plants, and hesitation with some people to work in the treatment plants like effluent treatment plant or sewage treatment plant. So we can come out of those problems with automation. Before that, I would like to bring your notice into one of the key statistics in India. So with respect to the sewage generation, only 22% of the sewage that is generated in India is being treated, which means around 78% of sewage is not being treated currently in India. This is the this data is taken from CPCB report itself. And out of the 22% sewage is being treated in the STPs, only 39% of the STPs are giving the output meeting the regulatory requirement. and rest of the 61% is not at all meeting the requirement of BOD, COD, and many other parameters. So that is the current state of treatment plants. Unfortunately, with respect to effluent treatment, there is no data available since it is very widely spread and it is dependent on industries. So this data is available with CPCB, which we are presenting to you now. So this shows that one is the treatment is a challenge, and another thing is collecting all the wastewater or the sewage and treating it with the treatment plant is another challenge. So when we have a treatment plant, but we are not able to run it properly, there can be two reasons. One is it might be having some infrastructural gaps, or it may be having some operational gaps. These are the only two possibilities that are there for a treatment, for a dysfunctional treatment plant. But if when we have infrastructural gaps, it needs some design and engineering modifications. It requires some additional infrastructure to be added. It needs some modification with respect to the flow and quality. So these are the general things that are required for an infrastructural gap. But when it comes to operational gaps, it generally happens because of standardization or unskilled manpower who are operating the plant. So automation plays a very important role in overcoming the operational gaps, overcoming the dysfunctional treatment plants because of operational gaps. So automation is something that is used to automate the entire process of the treatment. It may be effluent or sewage treatment, considering it's based on the process that the treatment plant is designed with. Automation can be implemented to any technology, any capacity. So there is no limitations or or there is no barrier to implement automation. It all depends on the process that is there in the treatment plant. Nowadays, a lot of treatment plants that are being built by the government and even by private players, automation is already a part of that system. Because now everybody knows that automation is a very, very major requirement to achieve the efficient results from the treated water, from the treatment plant. Otherwise, depending on the manual operation, is no more feasible to get an efficient output from the treatment plant. So there are a lot of advancements even in automation also. Automation is not something new to any field, but there are a lot of advancements in the automation that are making it more feasible, more economical, and more easy to consider and operate also. I will be throwing some light on that in the coming slide. So automation with digital twin technology. So this is one of the important part. There may be treatment plants which are already having PLC and SCADA system which are already running in automation mode. But generally, these treatment plants will be very much away from the habitation place, or in industries it will be generally at some other place where there will be no people movement. So considering that, it is very, very unfortunate sometimes that the treatment plants are not monitored properly. It is left to the operators who operate the plant, and nobody will be really bothered about it. It is because that there may not be any skilled team to take over the operations. And one more thing is there is no data availability at hands. We have to depend on someone else to understand the plant performance. But using the digital twin technology, which is being shown in the screen, we can create a replica of the treatment plant that you have at any place in a cloud, with which we can understand the entire plant operation with just one single click. So we need not to depend on any person or any operator or any supervisor to understand the plant performance. Like this in a single screen, you will understand the entire plant with respect to the quality, quantity, tank levels, the status of treatment. So all these things can be understood just with one single click. That is the advantage with automation when clubbed with digital twin technology. So we don't have to be depending on persons. We don't have to be depending on visit of the plant to get the details of the plant, or downloading the report from SCADA. None of these things are required. We can just do it from the cloud when we just have internet connection with our systems. So this is the digital twin screen of one of the plant where it is already implemented. So what we get as an advantage from the automation of treatment plants is with respect to quality of water, which is a very important point for the reuse of the water. It always meets the legal and reuse requirements. So once the treated water is consistent in its quality, those who want to reuse it will be very happy to reuse it. Otherwise, they will be under some fear that if the treated water quality is bad, then it will affect their process. It may be a boiler or chiller or cooling tower or industrial process. So it is very, very important to give the confidence to a person who is using the water that the treated water quality will be always meeting the reuse and legal requirements. So that is one important thing. So automation helps to achieve that. It can even reduce the manpower by 30 to 80% depending on the plant technology, capacity, and layout of the plant. Even we can achieve energy consumption by 20 to 30%. We can even reduce the manpower cost by 30 to 60% from the automation. Because automation having with digital twin will eliminate the need for one person to monitor the plant also. When we have an automation, only automation with HMI or SCADA, again we have to have one person to monitor the plant because we don't get any alerts from the plant. We don't understand what is happening in the plant unless we visit and look at the SCADA system or HMI. But when we have a digital twin technology, we can have all these alerts generated, assuming that we want an alert when the tank level is high or when the treated water quality crosses some limits. So all these things are possible when automation is clubbed with IoT and digital twin technology. So with that, we can eliminate the one person who is required to monitor the plant continuously. And only whenever there is some irregularities, we can assign some other person who is available in some other work also to attend this problem and solve the issues. So with that, we can reduce manpower and consequently, we can even reduce the manpower cost also by 30 to 60%. Generally, the automation systems can give a return of within 1 to 3 years. So it's not that automation is only capital intensive, but with that capital, you can get the returns within 1 to 3 years. One is by reducing the cost of operation and another second by reducing your freshwater cost, because in most of the places, the freshwater cost is more than the recycled water cost. So considering that if you opt for a freshwater always for the industrial process, then we are removing one option of reusing the treated water for the industrial process, which is cheaper. So hence automation, once it gives a consistent quality of treated water, we will be able to reuse that water in the process, with which we can even reduce the freshwater consumption and subsequently reduce the cost of water. So considering this energy saving cost, manpower cost, and the freshwater cost, we can get the ROI within 1 to 3 years. And we will have a live monitoring and data storage options 24/7. That is another important thing. So at any point of time, from anywhere, we can know what is happening in the treatment plant. Since we are not dependent on anyone, it will be very easy to monitor, and there will be a lot of data that will be available. As I said earlier, in a conventional treatment plants where people are manually being operated, so we will not have the data to understand the plant performance or to even optimize the plant operations. That is a major drawback. And we all know that we have to work with data and not with some assumptions. So once we have a real data in our hand, which is continuously stored in the cloud, it helps us to understand the plant performance, optimize it in terms of maybe power consumption or in terms of quality or quantity. So that will again enhance the efficiency of the treatment plants. So these are all the advantages that we get with the automation of the treatment plants. And as I said earlier, automation is now becoming an integral part of any new treatment plants that are being built. A lot of our clients and even governments and industries are showing a lot of interest in automation because they understand that automation is the key to reuse the water to get the consistent quality. So these are the few advantages of automation having in treatment plants. So now I will be coming to the role of IoT, AI, and ML in water treatment and management. So till now we talked about the advanced technologies that are there and automation that is there to operate the plant. But the world is moving towards AI and ML. AI and ML is being implemented in almost all the places. But the environment field and especially the water and wastewater treatment field is something where technologies are get implemented in a very delayed manner. But good thing is that now that trend is changing and a lot of companies, lot of players are showing interest in adopting the new technologies into their systems, like using IoT or AI and ML in the environment, and especially in water treatment and management. So, what is that is being currently happening in the market, where the IoT, AI, and ML are playing a very important role in enhancing efficiency, reducing the cost of operation, and remote operation capabilities? I will just throw some light on that. So, first thing is with respect to water and wastewater treatment plant operation. Uh, as I said, the new treatment plants are coming with automation and integrated with IoT and ML. So IoT is a very important role to create a digital twin of the treatment plant, with which we can even operate the treatment plants remotely. It is not that only with IoT we can only view the plant live, but in case of emergencies, we can even operate the treatment plants from any place, wherever we are using. It may be from mobile or it may be from laptop. So that is one important place where the advanced technologies are being implemented. And predictive analytics of water demand and supply, where we have a huge townships or cities where the water supply is a very important part, and understanding its demand based on a lot of variables. It may be climatic conditions, rainfall, and the people, number of people. So it is very important to have that water supply and demand requirement for that place, based on which the demand can be met. So the IoT, AI, and ML is playing a very important role in that, which this was being done manually previously with very less efficiency, one thing, and we were not getting very good outputs from that. But now the technology is changing that. And then this is also being used in smart leak detection and water loss prevention systems also, where especially in the pipe systems, where there are chances of loss of water due to leakages or corrosion or damages in the pipeline. So this generally, when we have a very huge network of water supply, it is very difficult to monitor or to track these leakages. So the technology is playing a very vital role in that. I will explain how it is. And another important place is real-time water quality monitoring. So this is a very important part of technology that is helping us to understand the quality of water that we are using. It may be in industries, or it may be in our houses, or even in any other place, or it may or also in the rivers. There are real-time water quality monitoring clubbed with IoT, which is transmitting live data to the cloud, in which we can see the current water quality. Earlier, we had to depend on the labs, which were giving the result after some 1 week or 10 days. By the time we would have used the water, but we are not knowing what is its quality. But the real-time water quality monitoring clubbed with IoT is helping us to get the water quality in our fingertips instantly. So these are the places where IoT, AI, and ML is playing a very huge role in terms of water conservation and reuse of water. So I will just come with one by one. So here, first case study is about water and wastewater treatment plant operation. So I'm just explaining a case study of a co-work space in Bangalore, which has adopted an IoT-based sewage treatment plant operation system into their existing plant. So earlier, this treatment plant was being operated manually, and there were people were there in all the shift to operate, but still they were not able to reuse the water because it was not meeting the quality requirement. So after this IoT-based system was implemented in their STP, so their freshwater consumption got reduced by 30%, because they are able to reuse this treated water for flushing and gardening purpose. That is first direct requirement, in which the freshwater consumption is reduced, and their cost of operation reduced by 50%, because there is no need of manpower to be present at the site 24/7. So the people can be there available in 4 hours or 8 hours only in the plant, with which the requirement of 2 additional manpower has come down, because of which the cost of operation has reduced very significantly. Generally, these treatment plants, it may be an effluent treatment plant or a sewage treatment plant, are not operated not operated consistently by its owners, is because of two reasons. One is because it is considered as a very high operational intensive. It requires high energy consumption. It requires high amount for the salaries and other things. That is one important thing. And second thing is the belief that we cannot get consistent quality of treated water. So then if we cannot get it consistently, then why to operate? This is what the people who are operating or the owning the treatment plants will be having always as a thinking. So to come out of that, when we have this advanced treatment systems installed, so first thing is it reduces the cost of operation. So once the cost is reduced, everybody will be showing a good interest in how we can better the plant with the very less cost. That is one thing. And once they are able to see the consistent quality of treated water coming out, so that will again gain their confidence and helps to operate the plant in a good manner and even allocate some good budget to that. So this IoT-enabled treatment plants can do that. So with respect to that, the cost of operation can be reduced and even energy consumption also can be reduced by 15%. In this plant also, it was reduced by 15% based on the equipment controlling done, based on it may be on the tank level or it may be based on the requirement or timing. So with all these optimizations done with the use of technology, so it's a win-win situation. It's a win situation for environment. It's a win situation for the person who is using the treated water or operating the treatment plant. So this is a very important place where IoT and ML is playing a very important role. ML helps to analyze this plant data. So once we have an IoT system, we can transfer the data to the cloud and have it. But if we just have it in the cloud, it is not enough. We have to again analyze it. So ML and data analytics helps to analyze that data and take further actions based on the requirement and to optimize the plant. So this is one of the case study of where IoT and ML is used for water and wastewater treatment plant operation. Then second case study is with respect to predictive analysis of water demand and supply. So as I said earlier, the supplying having to know water demand at various period of time, it may be within a day or within a month, it will help the utilities to supply the water in a consistent manner. Even in industrial units also, where the government bodies like KDB or BWSSB is supplying the water. So it is very important for them to understand what is the water demand and based on which they can be ready for the supply. But how to predict this demand and be ready for supply? That's a very big question because we will be having the data of number of people who are using it or number of industries that are using the water. But that can vary depending on a lot of factors. It may be seasonal variations, it may be rainfall, it may be temperature. So all these things plays a very important role. But once we have a very good data about the historical water consumption from that or of that region, so we can use the ML models. There are different ML models like LSTM or by LSTM MLPs, which can be used to analyze the water demand and supply requirements. This was done in Greater Melbourne, Australia. So they had this historical daily water supply and demand data of almost 20 years. So that's a very good data because this ML AI works very good with more data. So once we have good number of data to analyze the things, it will give us a very efficient results and implementable results to us. So at this historical daily water supply and demand of around 20 years was available and with climatic variables such as rainfall, maximum temperature, season. So all these data were available. So ML model was built upon this data to understand what is the water supply required, what will be the water demand in future days or months. So the ML model was able to forecast water demand data with almost 70% accuracy. And with more and more data being fed to this efficiency can be increased to even a greater extent. So once we have more data and our ML model is trained with that data, so we will be able to achieve efficiency of even more than accuracy of more than 90% or so, from which we can rely upon this data and maintain our systems accordingly or supply the water accordingly. So this is one of the paper that is published in IWA Water Supply Journal. This is openly available in the internet also. So this is another key place where the ML is playing a very important role in water treatment and management. Uh, Okay. So, with respect to the technology, use of technology in the treatment plan, so what is the current challenges and what is the road ahead and how we can be prepared? It may be a small industry or it may be a big industry or a utility system. So how we can be prepared for this, the imparting this technologies into our systems and improve our efficiency. So the what are the current challenges that are there to implement these advanced technologies are one is data challenges. So as I said, very limited data availability with which it is not possible to prepare any model in terms of AI or ML. So we need to have more and more data available. The more the historical data available, the better will be the model and better will be its efficiency. So data challenge is one thing. So what we can do is we can first collecting the data with respect to the analyticals that we want to achieve in our systems. It may be water consumption data, or it may be the water consumption requirement in each processes, treatment plant reuse capability, treated water reuse patterns. So we can have all these data. If we don't have it, we can start gathering these data based on which these new advanced technologies like IoT, AI, or ML can be used for that. And another important thing is the data quality and consistency. So when we build these AI or ML models, it is very important to have it in a this data has to be in a very consistent manner, and its quality has to be good. Quality of the data means one is its accuracy, that is very important, and second thing is its consistency. So when we have the data in a very periodical manner, it will be very helpful with respect to the development of the model. We should be collecting that with respect to date or weekdays, and even with respect to the quality of the water, quantity of the water. So all these data available, more the data available, more it will be better to build the model based on this data. So to overcome the data challenges, we should be ready to start collecting the more and more data as much as possible. Immediately to do that, we can rely upon IoT systems which transfer the data from your existing systems to a cloud, or otherwise we can ask our existing manpower system to record these data in an efficient manner as much as possible. But use of IoT systems is something that is very much feasible. In industries, what we can do is when we have a flow meters, we can make all these flow meters and the sensors data to be fetched, to be transferred to online using the IoT systems, with which the data will be always available. So these data can be sent to the cloud depending on our requirement. It may be done even for every minute. It may be done for every hour. So that thing is entirely customizable. So more the data we try to collect, more better will be for us. And there are technological barriers also to implement these advanced technologies like AI and ML, especially with respect to water and wastewater treatment, because there are not much players who are developing the models for this type of water and wastewater treatment systems, because this is a field, as I said earlier, the technology implementation is not done in a very aggressive manner. So that is one technological barrier we have. And one more problem what we have is real-time processing limitations. So since these models and all require continuous power and continuous data availability and continuous processing systems, and even in cloud or at site, so that limit real-time processing systems non-availability can be another technological barrier. But we can overcome this if we are very much intended to increase our efficiencies. And as you all know, currently these advanced technologies are high capital cost and limited ROI opportunities. Capital cost is something that is a challenge that is always there to overcome. But maybe with more and more implementation, this capital cost may come down in future. That is one hope we have. And skill and knowledge gap. One more important thing is we have people who are experts in AI and ML. We have experts in water and wastewater treatment or management. But it is very important that AI and ML expert is having knowledge about water and wastewater treatment, and this water and wastewater treatment person is having knowledge about AI. Then only this combination or merger of two different fields can be done together to achieve a better result. But that is a very, very scarce condition as of now, we don't have that type of experts having both the expertise in technology and also in the treatment and management process. So that is one important challenge that we have. So to overcome this, we have to understand about these technologies more and more, and how we can customize this to our sector. So it is not, AI and ML are not new. As of now, it is being widely implemented in a lot of sectors, but for our sector, mainly for water and wastewater treatment, management, and conservation, it is very important that the experts try to explore these types of new technologies and build our own models or build our own requirements for implementation of the technology. And there is always a resistance to change. We all are not, I don't say we are, but most of us are very happy with what we have, and we fear that what if we change something, there may be some negatives that may happen, or there may be some fluctuations that can happen. So that resistance is something that is a challenge that which we have to overcome with more and more proven results. That is the only thing. Earlier, even when membrane systems were introduced, people were hesitant to use it. But now, membrane treatment systems like RO, UF, membrane MBR have become a very common thing. So, like that, maybe in future, once people start using these technologies more and more, maybe this resistance will be overcome. So this is with respect to the advanced technologies with respect to water and wastewater, and what are the tech-driven opportunities that we have in our field in the water and wastewater sector. So I will be just briefly touching about our organization. Our company is Paryaavarneer Engineers and Consultants Private Limited. We are a team of more than 150 people. We are already implemented more than 30 projects in terms of water and wastewater treatment. So we started in 2017, and we have been given with different awards and recognitions also. We offer our services in different verticals. One is water and wastewater treatment, licensing and compliance, and ESG. Automation is also one of our key focus area in terms of water and wastewater treatment. These are the three verticals, and these are the offerings that we do in terms of our current verticals. And these are core team. Myself, I'm the chairman and managing director of Paryaavarneer with MTech in environmental engineering. Retd is my partner. He's also MTech in environmental engineering. And Mr. Amog is done MS in environmental engineering, and he is a director under ESG. SMR Prasad sir is a director. He's one of the backbone of our company, and he is a mentor for us. And Mr. Raghu is one of the director having a background in BSc chemistry. So we have our presence across Karnataka, and we are expanding to southern India also. If you have any requirements, we can contact us. Thank you.
Yeah, thank you very much, Arjun. See, for me, the entire presentation, it was little, it was almost 1 hour. It was like a storyline. So I can clearly see that whatever you have presented, it is coming from your experience, of working with industries and giving them solutions in the water and wastewater management. Because clearly you started with the various membrane filtration systems, because these are the things which came as tertiary treatment and improved the quality of treated water and also meet the stringent standards set by the Pollution Control Board. And then you spoke about, of course, you covered the various aspects of membrane filtration, and we know about that. Then you came to the automation, which is the order of the day as of now. And as I said, automation is something which can be effectively used to manage the treatment in a consistent way, because it's important to meet the requirements on a, I would say, on a real, real-time basis, and this can be done only through, automation. So, digital twin is something which has revolutionized the entire, industry in terms of technology. So without the presence of any manual, intervention, remotely we can manage the processes, whether it is manufacturing, maintenance, or it is wastewater treatment. So another important thing is, your explanation was very, very simple and very clear, because for me, I understood everything what you spoke. And I am sure that the participants with the background of environmental engineering and operation and maintenance of treatment plants should have understood very well. So you spoke about IoT, then AI and ML. So what is, the interesting part is that you also spoke about we can recover the cost, anywhere between 1 to 3 years. This is what you said. But beyond that, you also spoke about how prediction can be made. This is what I said we are working on in Bosch for predicting our demand for fresh water, because this is something which is going to be a big challenge in the coming years. Already with summer, we are seeing water shortages, even though last year the rainfall was above normal, and still our reservoirs have sufficient capacity of water across the country, but still water is giving mm, sleepless nights for, for the people who are managing water resources. So, and something which which was interesting to me was you spoke about LSTM, short-term memory, where it can be used for estimation and prediction of water demand by industries, and it can be also used for various municipalities and city corporations. It will come in the days in the future. It has to come so that we can efficiently manage the fresh water. So, but coming from the industry, what is one thing we need to convince our management is one side is ROI, return on investment, and the other side is what is the advantage in the long term to the industry in terms of securing the, I would say, the water management for the industry, because we know that water is going to be one of the key factors while it is deciding product distribution in multinational companies. So multinational companies are using water as one of the key decision making when they want to distribute their products to different regions. And India being a tropical region with, as I said, uh, with a lot of issues with respect to availability of water. So such technology and predictions would certainly help to convince their, bosses, whichever the country they are coming from, that we have a system in place which can predict the water consumption, and they can give that security feeling, so that India gets more and more products for manufacturing, and it becomes manufacturing hub for the whole world. So thank you very much, and now the forum is open for questions, and we can take it. There are a few in the chat box. Roopa, can you just take over?
Yes, sir. Thank you, sir. And thanks, Mr. Arjun. And to all the participants, we have enabled the audio and video. Please go ahead in sharing your queries.
See, I had a couple of points. Yeah, somebody
Yes.
please go ahead. Arjun, there is something like a smart operation system, which we have seen that which can be a replacement for multi-effect operators. And it gives the advantage that because ME needs a diesel, whereas the smart operation system works on energy. If it is coming from renewable energy, then it is fine. And also, if you have excess heat within the industry, then you can use this heat to this smart operation system. So have you done such projects?
No, sir, we have not done that product, but yes, we have heard about this projects, and especially when we have a heat within the industrial systems already available as a waste heat, especially. So this is a very useful system because, as you said, MEE or MER will require a huge amount of steam and with some good pressure. So when we already have it available as a waste heat, so we can use this waste heat to generate the steam on with which we can run our entire ME or MER system. But again, incorporated into the smart evaporation system is a very useful technology for sure. And again, as I said, so its implementation is something, when it's done in a larger scale, people will show more interest upon it, is what I understand.
Yeah.
And all these are very helpful for the sustainability with respect to the water, because a lot of industries require the sustainability of water with respect to water. Maybe in other factors, they may be sustainable with respect to the demand of the product and other things. There may be some good sustainability, but with respect to water is something that's always a challenging because it's not in our hands. It is dependent on rain and a lot of other factors. So achieving that sustainability with respect to water availability is a very important tool, important point for industry success also.
Yeah. Yeah, Murali Krishna, you can go ahead. You have raised your hand. You are on mute.
Yes. Good evening, Mr. Mohan and Mr. Arjun. Thanks, Mr. Mohan, for the wonderful interaction and the presentation. So my question to Mr. Arjun. So you were telling about uh, the new membrane system, and this will not work under pressure, right? So ultrafilter is under pressure, so there will be a lot of load on the filtration. So membrane also will have the pressure, right? Because the water should flow and it should pass through. Or the membranes will attract the foreign particles and it will hold. So how it will work? That is one question. And second is on this. There is a gray water, which is actually the soap solution or wash, which is more, and the kitchen waste, which is coming in the water, and there is a ETP. So these are the different water systems. And if I'm not wrong, the today with the so much medication in a house, and every day the water quality will change, or the parameters will change. In that case, you have to do a lot of adjustments. How the automation will work, and how the automation will surprise, and even for the ETP, for that sake, the parameters may be same, whatever, but the output no one can predict. Maybe 80% they can predict. So the dosages, how automation will work. So these are the two questions. Thank you.
With respect, yes, with respect to the first question of with respect to ultrafiltration. So ultrafiltration, as I said, is having we have it in two forms. One is in pressurized and submerged systems. So in pressurized systems, we require a pressure of around 1 to 2 bar only. We do not have to go provide high pressure like RO, where we provide around more than 8 bar or 10 bar. So ultrafiltration systems work in low pressure. But what happens is when it is in a even though when we are pushing the water with that low pressure, but if it is having more solids, so those solids can block the membrane in a pressurized system. But when it comes to a submerged system, we are not forcing the water to pass through the membrane. Instead, we are sucking the water from inside the membrane. So that is a difference. So in that case, what happens is those solids will not get clogged into the surface of the membrane or the pores of the membrane as much as it can happen in a pressurized system, or the damage of the membrane also. So the damage of the membrane also will be very less when we are not pressurizing the water with solids. Instead, we are sucking the water from within the membrane system in a negative pressure system or vacuum system.
Okay, that means it is a suction.
It's a suction, yes.
Suction. So
That is in an MDR.
Yeah, but even in the section, do you mean to say there will be no pressure? The reverse pressure will be there, no? But the membrane definitely will get damaged, right?
Yeah, but the thing is that the nature of the solid matters a lot here. Since these MBR systems or the UF systems are used after some filtration, or when it comes to MBR, I will first talk about MBR. So when in an MBR system, when we use the submerged membrane system, generally there will be a fine screen which will remove the particles up to around 2 mm. So one thing is that we will not have any those bigger solids or some inert solids which can damage the membrane. So most of the solids that would be coming into the membrane system would be already organic in nature, and it will be in the form of MLSS only. So there is no foreign particles that will be there which can damage the membrane. So that is one advantage in the membrane system. Even though with the suction, that damage will not happen. And that is how we ensure it. By having a fine screen of up to 2 mm, we ensure that. Because generally, whatever solids which are less than 2 mm, generally it will be organic in nature, is a very broad assumption. And also it's proved also with some analysis. So hence it is not dangerous to the membranes. But when it comes to the pressurized systems, and when we are using it after some treatment, if there is a contamination in the tank, or if there is any other means by which the water gets contaminated with some external particles, then that is one of the dangerous thing that can cause damage to the membrane. And even if we are having some biological solids also, so these solids can clog in the membrane, because this is pushing the solids into the membrane, in which that membrane pores, since it is very, very small, it cannot allow that. But there is a pressure from behind to push that. So because of which it can get stuck in the membrane pores. Again, removing that will become a very big problem, and because of which the membrane clogging or damage can happen. So this is the major difference between a pressurized system and a submerged system. So hence submerged systems are more advantageous compared to handling the solids. And with respect to your, sorry, I think I missed the second question. If you can again come up with that, sir.
Yes, sir. Yes. I know. So it is mainly on the water parameters which will change, because today in the process as well as in the STPs, the lot of medications are happening, and people to clean the toilet or anything, they use lot of chemicals, Harpic or whatever it is. So this will cause the damage to the water body, and this water will become more pollutant than the actual supposed to be. So how the automation will work in those cases? Because I see a lot of manual intervention is required today. Any flats or buildings or any communities, if you take, so today's parameter will not be there. That is why a lot of manual operations are still there. So nobody is getting the confidence on AI or ML or the automation. So how the awareness will be there, and also how the automation can manage this?
Yeah. So first you asked about the water with respect to gray water or black water. So currently there is a very big discussion is going on with respect to separation of water. So conventionally till now we are combining all the water together. It may be gray water or black water, and treating it in a common treatment plant. That is a sewage treatment plant. But now there is a discussion is going on whether we should separate the gray water and black water, treat it separately, because both water constituencies are different and sources are different. So this is a very big discussion that is going on. But if you ask me personally, even even I am not sure whether we should separate or not, because both are having its own advantages and disadvantages. So it all depends on where this treatment is happening. For example, if we are doing this treatment in an apartment, considering an housing society having a very huge number of houses, so and if we are separating these two separate waters, so first thing is that this gray water requires a chemical treatment. So who will do the chemical treatment, and to what preciseness, accuracy is a very big challenge. Yes, automation can play a very good role in that, for sure, no doubt, because we can have the sensors, and depending on the pH and other the constituents parameters, we can monitor the chemical dosings accordingly and get a better result. But again, monitoring that is a one important aspect. And second thing is that if we have a separate black water treatment system, but again after treatment, where this will be reused. So that is the second question. But currently what is happening is, since these treatments are combined at one place, so the treatment system is one, and we can have only one automation system or one manpower management system to operate and run the plant. So as of now, it is the most a better treatment system that is being helping to reuse the water, because we have to consider here not only the treatment part but also the reuse part. So the separation of grey water and black water is a very debatable topic, and I really don't want to tell what is right and what is wrong. But it may be with separation or without separation, even with respect to changes with respect to the treated water quality. Sorry, with respect to changes with respect to incoming water quality, we can have different sensors which analyzes that changes, and we can configure the automation system in such a way that the entire aeration process or chemical treatment process is varying depending on that. For example, assume that we want to go with some chemical dosing, okay, and that chemical dosing is always dependent on pH plays a very important role. So if the incoming water pH is less, then we can increase that chemical dosage automatically using the automation. But generally in manual operation, what happens is no manpower will see the water quality or test the water quality for every 1 hour or 2 hours. So so in that case, that treatment efficiency will be directly lost. But when we have the automation system with efficient sensors, we will be able to measure it continuously and monitor and vary our chemical dosage accordingly. One is we will get a very good quality of treated water, and sometimes we will even save the chemicals also, because again, usage of chemicals without need is another crime that we would do, which we should not be doing according to me. So these two problems can be eliminated when we have an automation system for chemical treatment. But when it comes to biological treatment also, depending on the inlet constituents, like it may be BOD, COD, now we have the BOD, COD sensors with which we can configure the aeration systems, also the blower operations, because blower is one that uses huge amount of power in treatment plant. So we can optimize its performance based on the BOD and COD load into the plant, even though the treatment plants will be designed for some BOD and COD load, but that load can change during the course of operation. So to make that be adopted into our treatment system, so it is better that we do not we employ the automation system, and it is led to the controlling system to monitor that completely, rather than a manpower is monitoring continuously and varying the aeration systems, which cannot be done precisely and accurately for sure. So that is how automation can help in optimizing the treatment systems, even if it is separated treatment system or a combined treatment system.
Yeah, thanks, Arjun. I have one last question from my own experience. NBR
Yes,
has certain limitations when, there are few things which can come in the way of the yield from MBR, the efficiency of MBR, and other is on the life of the MBR. So how to overcome this?
Yeah, so life of the MBR is something that can be extended depending on the maintenance. We have seen a lot of treatment plants where MBR membranes are being used even up to 7 years, the same MBR membrane. So why it can be done is, again, automation is playing a very important role in that. In an MBR system, the maintenance cleaning and the cleaning in place plays a very important role. So automation can make the CIP happening very precisely as per the OEM's recommendations, and based on that, based on which the membrane life will get enhanced. So even all the OEMs of the membranes say that once we are doing the precise chemical cleaning and maintenance cleaning, the life of the membrane will be extended for sure. So that is one place where automation is helping. But again, with respect to maintenance, and again with respect to a lot of places, there are two problems that we see with respect to membranes. One is physical damage and another is chemical damage. So physical damage is something that can happen when we do not have a good pre-screening system before MBR. So it is very important to have a fine screen of 2 mm level so that there is no foreign particles that can come into the system. And second thing is that with respect to chemical damage, it is something that can happen in an effluent treatment plant where maybe that MBR membrane is not physical chemically or it is not suitable for exposing to some type of chemical. But that chemical, if it is coming in the water, that can damage the membranes. But so for in that cases, we have to ensure that the entire array of parameters is analyzed properly before we adopt to an MBR system. So life of the membrane is as much from our experience, it mainly depends on the maintenance. As I said, cleaning in place, maintenance cleaning, and also physical cleaning. When the TMP is higher than the set limit, we have to sometimes physically also clean the membrane. So that also has to be done to ensure that membrane life comes to a good level.
Yeah, thank you. Thanks, Arjun. And I think we are almost coming to the end. Oh, it was very interesting discussion. I think the participants also can get in touch with you and your organization if they need some support. Now over to Roopa and the Colonel.
Thank you, sir.
Thanks, Mr. Arjun, for such insightful information. And actually, many of the participants have already expressed their thanks, saying that this was quite an insightful interaction. And we look forward to have many more sessions in the future as well. Thank you once again for your support in this initiative. Thank you, sir, for moderating the session. And thanks to all the participants for being part of this. And if you have any further queries, please do share it to us for us to share it to Paryaavarneer, and they will get back to you on their response. Thank you all once again. Thank you.
Thank you. Thank you very much.
Thank you all. Thanks to BCIC for giving us this opportunity.